आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सॉल्यूशन पाओ। डाउनलोड नाउ।
Okay, so the given question here we have is that the angle between the tangents at any point P, okay, so we have an angle between the tangents at any point P and the line joining P to the origin, okay, where P is a point on this curve x square plus y square equals to k tan inverse y by x, and basically this should be k here, k is a constant, right? This should be k is a constant. So I'll explain to you first what the question is trying to say, right? So suppose I'll make a diagram first. So if this is our curve here, let's make a curve here. If this is our curve here, right? And what we have, if this is our point, this is the point, right? At this point we should draw a tangent first. The tangent should looks like okay, I'll remove it. The tangent should look like this one, and similarly this point P is the point which is connecting to the origin and making a line what PO. So this is what O. So let's take this first point as x1 comma y1, right? And this is the tangent and this is our curve, you know. So basically what question is trying to say that the angle between the tangents at any point P and the line joining P to the origin. This is the line joining P to the origin. The OP is a line on the, and the angle between these, the tangent and the line, should be something theta, and this should be independent of what x and y terms. This is what we have to prove in the question, right? So how we can prove this one? If we have slope of this line m2 suppose, and this is a slope of this line as m1, so if our theta, we have to find out the slope using tan theta. Then if our tan theta is independent of x and y, right, then we can prove the situation of this question. So what do we do first? We have a solution here. We know that our equation of curve is what? Log of basically x square plus y square. Basically this is ln here, I'll be using log, same thing, log x square plus y square, which is k tan inverse of y by x, right? So first what we have to do, we have to find the, yes exactly, we have to find the dy by dx of tangent. Using this equation I can find the slope of tangent. Basically I have to find m2 using this slope, or I can say m1. So first I'll find m2. So this will become what? If we differentiate it with respect to x, we will get the value as 1 by x square plus y square, and here we have 2x plus 2y dy by dx, right? And this side we have k with the product of 1 plus y by x, right, whole square, this one with the product of, in the denominator we have, okay, x dy by dx minus, this will become what? This will we have minus y with 1, right, and this will be our x square. Okay, so what do you do? Now we can write this equation as, this equation can become 2x plus 2y dy by dx, right, divided by x square plus y square, right, and this side we have k with the product of x square divided by x square plus y square. If we solve this, x square gives the becomes the numerator part, and this side will become what? Okay, we are left this one as x dy by dx, same as it is, minus y divided by x square, right? These are the values we have here. So now what we can see that some terms are cancelling out with each other. This x square with this one, right? The denominator part of both sides is cancelling out with each other. So we are left with now. So basically we are left with 2x plus 2y dy by dx is equals to kx dy by dx minus ky, right? These are the terms we are left with. So now what we will do, we can write them down as, if we take dy by dx common, so we will get k x minus of 2y, right, dy by dx is equals to 2x minus ky or 2x plus, okay, 2x plus ky, 2x plus ky, right. So our dy by dx is here becomes what, 2x plus ky divided by kx minus 2y, right. Okay, I did a little mistake here. This should not y, this is only x here. So kx minus 2y, so I'll write it down it as here also. This will become, if I remove this will become here k of x minus of 2y. This is our dy by dx. So basically what we have to do, we are doing now, what we will do, we will find out our m2 here, which is dy by dx at the point P. At the point P where I already marked the coordinates x1 and y1. So basically they will turn out to be, when you put the values x1 and y1, 2x1 plus k y1 divided by k x1 minus twice of y1, right. This is our slope of what, tangent or norm with the line, the slope of tangent, slope of tangent. Similarly, how can you find the slope of line? Basically, what is the slope of line was m1. So our slope of line, which line, OP. If we have two coordinates given, can you find the slope of line OP? We have two coordinates. First one is 0, 0 for the line. Another one is x1, y1. So what will be the slope? y2 minus 1 upon x2 minus x1. So this will become y1 minus 0 upon x1 minus 0. So we are left with y1 by x1. This is our m2, right. Sorry, this is our m1. I've already marked it in the question before. So what do we do now? We know the m1 and m2. And how can you find the theta in between slopes of two lines? Okay, so basically we know the formula to find theta. So basically theta is what, m1 minus m2, right. And here it will become 1 plus m1 m2, okay. And the answer is in mods. It means that we can write it down as, twice of x1 minus k y1 divided by k x1 minus twice of y1 minus y1 by x1 with the denominator of 1 plus twice of x1 minus k y1 divided by k x1 minus 2y1, right, with the product of y1 by x1, right. If we more simplify this, so we are left with our tan theta will come out to be, this will become 2 x1 square plus k, this should be k or x1 y1, this should be our, basically this is our k x1 y1, a x1 y1, this is our minus of k x1 y1 again plus twice of y1 square, right. With this we are having denominator as x1 kx1 x1 kx1 minus twice of y1, right. Similarly the big denominator part we have here. Okay, so I'll write this down also, this one as here, tan theta should be written here. This is the denominator part now. So this will come out as kx1 square minus twice of x1 y1 plus twice of x1 y1, and this will be k y1 square. There's a little complication over there, but we can easily solve this equation if we are going step by step without making any mistake, right. So this will become twice of y1. Can we see things which are cancelling out with each other? Yes, this one, this one, this one, this one, and obviously the denominator part. So what we are left with now? So basically we are left with twice of x1 square plus twice of y1 square, right. And this one is k x1 square plus k y1 square. If we take 2 common from the numerator part, we are getting x1 square plus y1 square. Similarly, if we take k common, we will get x1 square plus y1 square. So now we can see that they are cancelling out with each other. So the basic thing come out to us as 2 by k, which is tan of theta, right? So basically this is the answer we are looking for, and they are independent of x1 and y1, right? So if we go to the question, what the question is trying to say, the angle between the tangents at any point P and the line joining P to the origin where P is a point to the curve is a constant, is what is it? It always is constant. This theta will always remain constant because the value of tan theta find comes out to be constant, which is independent of x1 and y1, these points, any point on the curve P, right? So that's why our answer will come out as 2 by k, and which is independent of x and y.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।